Hi, I'm Jay.
And I'm Stav. We're both engineers on the Android Auto team, and today we'll be talking about bringing your apps to cars using the Car App Library. When we talk about apps for cars, we're really talking about two things. The first is Android Auto, which enables users to connect their Android phones to compatible vehicles and use their favorite apps and services right on the car's display. The second is Android Automotive OS, where Android runs directly on the car, powering the in-car infotainment system, as well as giving drivers access to their favorite apps without a connected device. And lastly, for Android users without a compatible car, we offer Google Assistant driving mode, but we won't be focusing on that today. Android Auto continues to see strong momentum. It's now available in more than 100 million cars globally, with support from nearly every major car manufacturer. Android Automotive OS is seeing great traction as well. By the end of 2021, Automotive OS with Google built-in will be available in more than 10 car models from Volvo, General Motors, and Renault. And we recently announced partnerships with Ford and Honda to bring this experience to millions of future vehicles. These growing platforms represent an amazing opportunity for you as a developer, and that's where the Car App Library comes in. The Car App Library allows you to write your code once and make your app available across both Android Auto and Android Automotive OS. The interface is designed with driver safety in mind, which in turn helps you build apps that are safer without needing to become an expert on driver safety. Voice is an important form of input in cars, so apps built with a Car App Library enable you to have seamless integrations with voice assistants. And version 1.1.0 is now in beta, which means you can go to production with the most up-to-date APIs. Before we jump in, it's important to note that unlike phones where you get full access to the screen, in cars we are providing you with predefined templates that were carefully built with driver safety considerations. Our approach is to expose relevant templates to you according to your app's category, and over time build a cohesive library that allows you to build what you want. We are starting this journey with navigation, parking, and charging apps. Messaging and media apps should keep using existing Android APIs. If you're interested in bringing your apps to cars but don't fall into any of these categories, please reach out to us and let us know what you'd like to see in the Car App Library in the future. Now that we know what the Car App Library can offer you, let's have a look at the architecture. When your app is launched in the car, a host application running on either Android Auto or Automotive OS will connect to a car app service that you will extend. In your car app service, you will override onCreateSession, which returns a session instance corresponding to the current connection to the host. The session is responsible for returning the screen instance to use the first time the app is started by overriding onCreateScreen. Then, each of your screen classes will implement onGetTemplate, which returns a template object representing the state of the UI to display in the car screen. The template will be then fed back to the host application, which will render the UI for you. With Android Auto, you will find the same look and feel across all vehicles. And with Android Automotive OS, you will find the rendered UI influenced by OEM customizations, so your app will feel like it belongs in that specific car without any extra effort on your part. As I mentioned previously, when using the Car App Library, you need to declare a category for your app out of either navigation, charging, or parking, which will give you access to the corresponding templates for that category. All apps have access to the top 7 templates, while navigation and parking and charging apps have specific templates for their use case. Again, please do let us know what templates and categories you'd like to see in the future. Now, Jay will walk you through the code and show you an example of a simple car app.
In this section, we will learn about the Car App Library by building a simple Hello World app. We start with the code structure. Our codebase has 4 components. The first is our phone app component, where the code and resources needed for the phone app will be placed. Then we have the common car app component that contains all the car app code and resources. This component will be shared between the Android Auto and Automotive OS build targets. Next, we have the Android Auto and Automotive OS components, which just contain the Android manifest and the build.gradle files. With this structure in mind, let's jump into the code. Let's define the dependencies in our build.gradle files. For our app, we will depend on the 1.1.0 Beta 01 version of the car app library. These are the dependencies for the Android Auto build target. We have the shared car app library dependency, as well as the Android Auto specific dependency. These are the Automotive OS dependencies. Notice that the shared library dependency stays the same, but now we have the Automotive OS specific dependency. After setting the dependencies, we can write the main car app logic that works in both Android Auto and Automotive OS. First, we create our car app service class. This class is the main bridge of communication between our app and the host. In onCreateSession method, we return a Hello World session object, which we will go over soon. In our service, we also create a host validator to check if the host that binds to our service can be trusted. We use the default host whitelist here, but you can add new hosts if needed. Next, we create Hello World session. Session is the object that returns the first screen to be shown when the app is opened in the car screen. Here, we return Hello World screen, which we will revisit in later slides. Session also receives intents as well as callbacks on lifecycle and configuration changes. Next, we create Hello World screen. A screen object contains the template and the metadata that we want to show in the car screen. We construct and return a template object in onGetTemplate method. Also, Screen has access to the Screen Manager object that you can use to push and pop screens. We will see how Screen Manager works in the next slide. We will create a very simple list template with one row of text. First, we create the row object. When the user taps on the row, we use the Screen Manager to push the next screen. Then, we create the list with the row and create a list template. For the next few slides, we will show a few things you can do with the library. For a comprehensive walkthrough of the library features, please refer to the car app library developer documentation. Here, when the user taps on the row, we update the row text. The invalidate call notifies the host that the screen needs to be updated. In order to show a toast, you can use the CarToast class, as shown here. The usage pattern is the same as the regular toast class. To request permissions, such as the location permission, you can use CarContextRequestPermissions method. In Android Auto, calling this method will show the permission request pop-up in the phone screen. In Automotive OS, the pop-up will be shown in the car screen. In the callback, you will have the lists of approved and rejected permissions that you can act on. To send a notification, construct a normal notification object, optionally extend it with Car App Extender, and send it with Car Notification Manager. In Android Auto, Car App Extender allows you to differentiate the notification style and content between the phone and the car screen. In both Android Auto and Automotive OS, when the notification is displayed in the car screen, any content set in the Car App Extender will override the equivalent notification content. Congratulations for finishing the code section. We're almost there. In the next section, we will go over the manifest files for Android Auto and Automotive OS build targets. In the Android Auto manifest file, we add this metadata in our application element. This metadata allows Android Auto to identify your app as a car app. We also place the corresponding XML file in our resources directory. Next, we define the minimum car API level for our app. Higher minimum API level means that we can use the latest library features, but some hosts may not support the API level. When that happens, the host will display a message to update the host app. Since we are only using basic library features, we can leave it at 1. Then, we declare our car app service in the application element. Notice that in the intent filter element, we declare our service as a car app service, and also our car apps category as a parking app. The category declared here will later be used in Play Store app review process to check if our app meets the category-specific car app quality guidelines. The Automotive OS manifest looks somewhat different. Here, we declare various features that we are and are not using in our car app. Declaring features such as Wi-Fi and camera as false is important. Otherwise, our app may not show up in cars that do not support such features. As we did for Android Auto, we add the metadata so Automotive OS can recognize our app as a car app, and also declare the minimum API level. Again, our car app service is declared in the same way. Lastly, we declare an activity specific to Automotive OS. Notice the distraction-optimized metadata. This is needed for our app to work while the user is driving. That is it. Now you can build an app that runs in both Android Auto and Automotive OS. In addition to the library features, your car app can benefit from voice integration. Voice integration allows the driver to interact with your app without being distracted, and can also extend your app's functionality in many ways. You can receive intents from the voice assistant in your session objects onCreateScreen and onNewIntent methods. If you're building a navigation app and support navigation intents, you may receive intents from the voice queries. We will show you how to handle this intent in the next slide. In addition, your app may receive built-in and custom intents from Android App Actions, just like your phone app. For more information, please refer to the link in the slide. Here, we are handling the intent that we receive in onNewIntent method. The intent received in onCreateScreen method can be handled in the same manner. If the intent action is car context action navigate, we parse the query string, which we pass to the constructor of myNavigationScreen that we push. See the car context developer documentation for the exact format of the intent. So far, we wrote our Hello World app with the common code, dependencies, and the manifest files, and integrated with the voice assistant. Now is the time to see our app in action. In the next section, we will explain how to run a car app in Android Auto and Automotive OS emulators. The link in the slide has instructions on how to download and run the emulators in Android Auto and Automotive OS. Make sure you build and install your car app's Android Auto build target on the phone to run it in the desktop head unit. Similarly, build and install Automotive OS build target in automotive emulators. When you run your app in the emulators, you can also see the cluster display, which may show navigation or other relevant information. Also, you can test the voice commands in the emulators if your app is integrated with the voice assistant. This last section is about publishing your app. The process is very similar to the regular app publishing process, so we will only note the differences. To submit your car app, in the Play Store console, click Setup, Advanced Settings, and Release Types. Select Android Auto or Android Automotive OS depending on your car app's build target. When uploading your APK, select Standard Release Type for Android Auto and Automotive OS only for Automotive OS. After submission, there may be additional reviews based on car app quality guidelines. When the review is complete, you will receive a notification email with the result. I hope you will feel confident about building car apps and reaching out to millions of users on the road that need your app. To help you make great apps, we are working hard to add more templates and categories. We're also working on paid app and in-app purchase flows for Automotive OS car apps. Please reach out to us and let us know what you would like to see in the car app library in the future. Lastly, here are resources that contain more comprehensive and detailed information about building a car app. Thanks for watching.